So we know the three states of matter we learned in primary 4 or some schools in primary 3. They were solid, liquid and gas. Some things I know about solids have a fixed shape and they have a fixed volume, which means they cannot be compressed. Things I know about a liquid, they have no fixed shape, they are able to flow, they take the shape of the container they are put in, but liquids have a fixed volume, which means even liquids cannot be compressed. Hi V, yes, how are you? Yeah. Okay, and last we learned about gases. We know gases, they have no fixed shape and they have no fixed volume as well. Which means again, gases, they can be compressed. Now again, because gases have no fixed volume, gases in fact can be compressed. So we look at examples of water in these three states. Water is one of the very few, in fact, the only substance on earth that occurs naturally in all three states. Right? Very few substances you find that can occur naturally in all the three states in the same location. Right? Of course, in a science lab or under controlled conditions, we have different substances that can exist in three states, but water happens naturally. You can find water in the solid state, water in the liquid state, and water in the gas state in the same place. So water is one of the, in fact, I dare say the only substance that occurs naturally. Hi, I'm Coach Ryan. Hi Akhil, thank you for joining me. Yeah, I'm Coach Ryan here with BrainyMo Master Math Science. Yeah, we teach primary school science. Okay, so for example, water in the liquid form, we know that it is rain, for example, tap water, the water that we drink. Okay, these are more common forms, right? However, no teacher. Hi teacher. Hi Akhil. Yes, Akhil. Correct. Yeah, I used to be from. Yes, Akhil. Yeah. Okay, so we have rain, we have tap water, right? These are the more common forms of water. But however, the more uncommon forms of water is mist and clouds. Okay. Now, very often children confuse clouds as being made of gas, but however, remember, gases cannot be seen, but clouds can be seen. So clouds are actually made up of tiny little water droplets. Okay, cool. So water in the gas form is called water vapor, and there's another name for water in the gas form, and we call it steam. Now both of these cannot be seen. I repeat, both of these cannot be seen. So all that tiny little smoke particles or the tiny little cloudy particles that you see rising up of your hot coffee, your hot cup of noodles, your hot soup, all of that is actually water in the liquid form, which is mist. And we will learn through the course of this lesson where this mist comes from. How come there's mist? Because it's about a change in state. Now water in the solid form, the most common one we've seen is actually ice. Some of us on holidays, we would have seen snow. Right? All of this is examples of water in the solid form. And in fact, in 2013, if I'm not mistaken, in Singapore, we had freakish weather. Right? It was really hot, and all of a sudden, one day it just started to hail. So in the Jurong parts of Singapore, we started getting hailstones. Hailstones are tiny, marble-sized drops of ice that started falling. Right, so we will have hail. Now you can go and look this up when you're free. You can look up Singapore hail 2013. Right, you can actually go out there and look this up, and you'll see that in Singapore, of all places, right, it started to have hail. It's only one time, never happened after that, right? In order for water to change these states, what we have is there is a transfer of heat that is involved. Heat transfer meaning it can either be heat gain or heat loss. Right? And as water gains heat, of course its temperature increases, or when water loses heat its temperature decreases, but at a certain point in time something else happens. It changes state. Okay, it changes state. And when it changes state, it's a process that is happening. It's changing from a solid to a liquid, it's changing from a liquid to a gas, and these states, they have certain names and we call these processes. So in order to change state, water needs to go through different processes, and each of these processes need different conditions. Okay, each of these processes have different conditions. Right. Hey, thank you guys for joining me. Please, smash that like button. That will help us to, if we get to 50, 60K likes, we actually get Dubai chocolate that is given away today. Okay, cool. So these are all the processes, and as we go through these processes, the questions we ask ourselves is, what are the names of these processes? So the first key question we ask ourselves, what is the name of these processes? Second question we ask ourselves is, are these heat loss or heat gain? Because remember I said earlier, it requires a transfer of heat, right? So is it a heat loss or heat gain? And finally, we ask ourselves, how is the temperature affected? Or what is the effect on temperature, right? So the last thing we ask ourselves, what is the effect during these changes in state? Hopefully you kids that have joined me, you have these notes that were sent to you, right? Or if not, probably at the end of this lesson you can just get in touch with our Telegram channel right there. It's right on top, I think, somewhere further up, that says Telegram at Master Maths PSLE. Right. If you join there, you get the notes for today, right, and you can have a look. Okay, one of the first very common processes we will be familiar with, right, is actually what we call melting. Now, many of us have been, to fast food restaurants, to in fact even coffee shops. When we order drinks, they give us ice in a cup, right? And ice, eventually after time we realize ice starts to become water. What is that process? That process is actually called melting. So if you look at this, what is melting? Melting is when solid becomes a liquid. And the reverse is also true, right? The reverse of melting is actually called, can somebody type it out for me? Let's see if you know what the process for liquid becoming solid is. Anyone? Freezing. Thank you, Hirzan. Excellent. Right? Exactly, right? It is freezing. Freezing is when liquid becomes a solid. Now, there's a few other processes as well. Now, when we are enjoying that cold drink, what we notice is the suddenly water droplets that are forming on the outside, right? And that is thanks to this process called condensation. That is thanks to this process called condensation. So what is condensation? It is water vapor in the air, loses heat to the cooler outer surface of your glass and condenses, right? So this is basically gas becoming liquid. Now, finally, for liquid to become gas, there's two processes that actually take place, right? Evaporation. Thank you, Creek Craft. Yes, evaporation is one of them that makes a liquid a gas. Can someone tell me the other one? Besides evaporation, what else? Starts with the letter B. Boiling. Thank you, Irwin. Right? It is also boiling. Now, these two processes change a liquid to a gas. Right? Now, there's two other processes that happen, right? Very seldom, right? One of the process, I mean, not very seldom, it happens a lot, but I mean, it's not really something we explore in detail in primary school, right? One process is actually called sublimation. Anyone wants to guess what sublimation is? Anyone wants to try and guess what is sublimation? Solid to gas. Exactly, Irzan. Yeah. Solid to gas. So sometimes when you look at these glacier sites, right, where there's a lot of icebergs, there's a lot of glaciers, the solid actually does become water vapor as well. But it doesn't pass through the liquid state. It goes through a process called sublimation, where it directly just straight away becomes from solid, becomes gas. We would have seen that more frequently when we look at dry ice. You see the dry ice starts getting smaller. That is effectively solid becoming a gas straight, just bypassing the liquid state. Okay, and then we have another one, which is the reverse of that, right? From a gas, it can become a solid as well. Okay. And that process we call it deposition. So later on at the end of this lesson, you can probably go up. There's a lot of YouTube videos that explain these two processes in detail, right? What is sublimation and what is deposition. So now let's go through the processes, look at the processes a little more. Freezing is straightforward. Freezing is a process where what becomes what? Freezing of water, right, is a process where a liquid becomes a solid, or rather we say where water becomes ice. Now in order for this to happen, I need to put it in an environment which is very cold, such as in the freezer. Is anyone able to tell me what is the temperature in your freezer? Can you make a guess what the temperature inside your freezer is? Come, let's see if anyone can make a guess what the temperature inside the freezer is. It's a random guess. Yeah, you can just quickly throw out any numbers that come to your mind, right? What is the temperature in the freezer? Hey guys. 0, little lower than 0 actually. It's kind of lower than 0. Good guess though. Good guess, but it's a little lower than 0. I mean, quite a bit lower than 0. Any other guesses? No. Okay, I'm going to leave that for you to find out. Okay, it's definitely a negative number. It's negative something degrees Celsius. Probably at the end of this, you can go back and have a look at it. Try and find out the temperature. Okay, now in order for this to happen, right, minus 10, very good, close here, son, close. I'll leave that there for you kids to find out later today, right? Science is about curiosity, right, and knowing how to satisfy that curiosity. Okay, so going back, because it's in a cold place, what happens is this water loses heat. Water loses heat. And as the water loses heat, remember when an object loses heat, its temperature starts to decrease. So the temperature of the water decreases, and it keeps decreasing because the water is losing heat. So one important point you need to remember, right? When an object loses heat, I repeat, when an object loses heat, the first thing that can happen is a decrease in temperature. The first thing that can happen is the temperature decreases. Remember, temperature is the measure of how hot or how cold something is, right? So when it's losing heat, its temperature starts to decrease. The next thing that happens is actually this. Okay, the temperature of the water will continue to decrease until it reaches 0 degrees Celsius. Now the 0 degrees Celsius is a pretty important number when it comes to water, right? At 0 degrees Celsius, what happens is this, right? All the water will start to become ice. So at 0 degrees Celsius, while the water is becoming ice, while the change of state is happening, the temperature does not change. Okay, where it remains constant. Until all the water has become ice. Okay, so remember the second thing that can happen is a change in state, right? A change in state. So either a change in temperature or a change in state. And a very popular question in PSLE is, when we look at graphs later, you'll find out, they'll ask you, right? During the freezing of water, the temperature doesn't change, right? The temperature is just a flat line at 0 degrees. Does this mean water is not losing heat? Or a question could be phrased in this way, right? Why does the temperature of water remain constant during freezing? And many kids mistakenly come up with the idea that, oh, the temperature remains constant because water is not losing heat and it's not gaining heat, so its temperature doesn't change. But that is actually slightly incorrect, right? The actual reason is all the heat energy that is being given, right? All the heat energy that is being lost during freezing, all this heat energy that is lost is used to change the state and not change temperature. So remember, water is losing heat. It is just that the heat energy that is lost is used to bring these water particles or these water molecules closer together so they can fix themselves in a very fixed arrangement. So like we know that solids, they have a fixed shape because the molecules are arranged in a very rigid structure. So the heat energy that is being lost is actually used to do this. Once all the water has become ice, then its temperature starts to decrease again. And this number, we call it the freezing point of water. So we say 0 degrees is the freezing point of water. Okay, remember the key things here again. When an object loses heat, it either changes in temperature or it changes in state, and all the heat energy that is being lost is used to change the state and not change the temperature. So the water's temperature, the ice's temperature will only start to drop after all the water has become ice. It's a 1 hour session. Yeah, we'll be online until 7. Okay, I know some of us are fasting today. We need to prepare to get breakfast and things like that, right? So yeah, we'll finish. Hopefully we can finish on time. If not, maybe 5-10 minutes past 7. Cool. Okay, now let's look at melting. Melting is very similar, right? It's just the reverse. Again, a process where ice becomes water. In order for ice to become water, it needs to gain heat. And this heat gain is used to break these split up these particles, make them further away so that it can start to flow. So again, it gains heat from the surroundings. Again, as the ice gains heat, its temperature increases until it starts to melt and this melting happens again at 0 degrees Celsius. Okay, this temperature remains at 0 degrees Celsius for exactly the same reason, because the ice is going through the process of melting. And even during melting, it is gaining heat. It is just that, I repeat, the heat energy is used to change the state and not change the temperature. Again, the heat energy is used to change the state, not to change the temperature. So the temperature remains constant until all the ice has melted. And again, when all the ice has melted, all the ice has become water, the water's temperature can start to rise. And again, this means that 0 degrees is the melting point of water. So we have 0 degrees, I can call it ice, right? Melting point of ice, same substance in a different state, right? 0 degrees is the freezing point of water, 0 degrees is also the melting point of ice. Then we move on, we have boiling. Boiling is simple. Boiling is a process where liquid or water becomes steam. Okay, this is a process where water becomes steam. Cool, right? So what happens is, in order for water to become steam, again, it needs to gain heat. Water needs to gain heat. Now, those of us who are in primary school, I always recommend you go and look this up, right? You go and look this up in your free time. Like today itself, we have a few things to look up, right? What is sublimation? What is deposition? What is the temperature in a freezer? And it's good that you look up this other thing as well, right? You go and look up this particle theory of matter. Again, on YouTube, there's a lot of science videos that you can learn from, a lot of educational videos that are there. So if you look at this particle theory of matter, you will understand a little bit more about what is this heat gain, what is heat loss, what happens to an object when it gains heat, what happens to an object when it loses heat. All right, it's all about the movement of these particles that are inside different forms of matter, right? So when you have some time, use this time, you go online, instead of wasting time on YouTube shorts or, looking at, funny videos online, spend this time to build up your science knowledge, right? Your science content. Okay, so go look up this particle theory of matter. In fact, there's many videos that even dumb it down for kids that makes it easy for children to understand. So the minute you understand the particle theory of matter, every time you look at ice gaining heat or water gaining heat or, water losing heat or gases losing heat, it'll make a lot more sense to you. Okay, it'll make a lot more sense to you. Right. So water needs to gain heat from a heat source. And when water gains heat from a heat source, number one, the temperature will increase naturally, same like before, right? The temperature of the water will increase as the water gains heat. But then it will reach a point, right? It will reach a point where the temperature reaches 100 degrees. So the temperature will continue to increase until it reaches 100 degrees, where the water changes state. Okay, this process we call it boiling, where the water boils and becomes steam. Now, one question, in fact, I think this is in one of the BrainyMo Instagram channels videos, where one of the students actually asked, right, Coach, is steam always only 100 degrees, right? Is it always only 100 degrees? No. Steam goes to really high temperatures, and it's responsible because steam has a very nice density. Okay, so they use this superheated steam to do a lot of things, right? They do use the superheated steam to do a lot of things. In fact, you can go back again, see, it's another thing you can look up online. You go and look at the invention of the steam engine and how that changed society, right? We know, dear, I'm no longer at Bendemeer. I used to teach at Bendemeer, right? It says math, but I'm teaching science. Oh, okay. Yeah, I know it says Master Math, but yeah, at Master Math we teach secondary school math, we teach English as well, we teach primary school science, we teach primary school math. So yeah, we have English, math and science. Math is taught even at the secondary school level, but for science it's just still at the primary school level. Right, so you look at this invention of the steam engine. For those of you who have time later, it's good. Right, you go and look at this invention of the steam engine and how that changed society. Okay, again, it has to do a lot with steam. This means that 100 degrees Celsius is the boiling point of water. Okay, 100 degrees Celsius is the boiling point of water. Can you teach math? I'm taking my N levels this year. Yes, ARC, there is N level math as well at Master Math. There is, yes. You just go on this Telegram channel, you ask them questions about when the lessons are, what lessons are there, or even on the website, you know, all information is right there. Cool. Okay, guys, help me out. Just smash that like button. We are at 1,000 likes. I think we need to get to something like 50 times what we are right now. Okay. Now, water has two processes in there, right? There's two processes, right? One is boiling, which we just learned, which needs 100 degrees to take place, and other is evaporation. Now, thanks to evaporation, right, our clothes can actually dry. We don't need 100 degrees in order to get the clothes, water from our clothes to, you know, disappear and become gas, right? So what is drying? It's effectively, it's water becoming a gas state, and that happens thanks to this process called evaporation. And in fact, evaporation is very important because it is an important process in what we call the water cycle, and the water cycle is an important process in order to make sure all living things get a constant supply of fresh water. So two processes happen. Two processes change water from liquid to gas. One of them is evaporation, and one of them is boiling, which we learned, and the other one is evaporation. Now, evaporation happens at any temperature between the melting point and the boiling point. Okay, it's a process where water becomes water vapor. So water in the gas form at temperatures below 100 degrees, we call it water vapor. Water in the gas form at temperatures above 100 degrees, we call it steam. For evaporation to happen, again, it needs to gain heat. It can gain heat from many things, right? It gains heat from the surroundings. It can gain heat from a heat source. It gains heat from the sun. It can gain heat from different heat sources, okay? Even from lights, you know, sharp lights that are there, right? And gains heat from the surrounding, and when it gains heat, it becomes water vapor. Now, evaporation takes place at any temperature between the melting point, which is 0 degrees, and the boiling point, which is 100 degrees. Again, below 0 degrees, we know water is in the solid state. Above 100 degrees, water is already in the gas state. So, you know, this is the temperature range. And we learned something new. We learned that, hey, from solid to gas, we call it sublimation. So at temperatures below 0 degrees, what happens is sublimation. Cool. Last thing is condensation. Condensation is also an important process that helps us to get fresh water. It's important in the water cycle, right? Condensation is a process where either water vapor or steam changes to liquid or changes to water, right? In order for this to happen, water vapor or steam has to lose heat. It has to lose heat to a cooler surface, right? So these are the 5 main processes in which water changes state. So now we're going to start going into a little bit of detail in what factors affect the different processes that happen. Now, when I have impurities, for example, salt or sand or whatever impurities that are dissolved, like even the tap water that we have, right? The tap water we get in, from the tap in Singapore, it's safe to drink, but it doesn't mean it's pure water. In fact, there's a lot of salts that are added in, calcium, good for your bones, fluoride, you know, good for your teeth. All of these are minerals and salts that are added into the water. So when we have these impurities, what happens is impurities do one thing. Impurities reduce your freezing point and your melting point and increase your boiling point. I repeat again, impurities do one of two things: reduce the melting point and freezing point, and they increase your boiling point. Now, if you had studied the particle theory of matter, you will understand a little bit more about this. It's because these particles hold on to these, these impurities hold on to these hi 3D. Yeah, better start studying now. Math is pretty easy, you're right. Okay, hi. Yeah, so what happens is these impurities hold on to these water particles and they prevent them from escaping and becoming gas, which is why it takes a higher temperature in order to change state. Okay, so again, it's good that you learn, the particle theory of matter, even though you're in primary school. It's good to read that. Cool. Okay, so moving on, evaporation. Evaporation happens at any temperature between 0 and 100 degrees. So we know what affects boiling, we know what affects melting, we know what affects freezing, impurities. But when it comes to evaporation and condensation, there's a little more water and its states. We're learning P5, end of P5 topic, water and its states, but it will be tested, a very heavy topic in your PSLE science paper as well. Okay, so these two processes have a few other factors that we need to consider. I'm going to focus on condensation first, and then we'll quickly go through evaporation as well, and we still have something called the understanding of graphs. Okay, cool. Right, so if I look at condensation, remember, needs warmer water vapor. It also needs something called a cooler surface. And when the warmer water vapor touches this cooler surface, it loses heat and condenses. Okay. So Anaya, hey, thanks for joining. Nice. I remember I told you on Monday. Thank you. Good girl. You'll listen. Right. Okay. So this temperature difference is what affects the rate of evaporation, condensation. I repeat. This temperature difference is the key thing, the key factor that affects the rate of condensation. When the temperature difference is greater, we have a higher rate of evaporation. When the temperature difference is greater, what we end up with is a higher rate of condensation. Right? And this higher rate of condensation means water droplets form easier because more water vapor can lose heat and condense, right? Because if there's a greater temperature difference, this happens. And many of us would have experienced this, those of us who wear glasses especially. On a normal day, right, we're walking around, we don't see condensation that happens on our... Sure, will we have Kahoot? Yes, we will have Kahoot. Yeah. We don't see condensation on our glasses, but the minute we go into a cold room, our glasses lose heat to the cooler surroundings in the cold room, and when we come out, our glasses are a cooler surface, and water droplets start to form. Or, for example, the colder the room is, when we come out, there's more condensation that happens. Because why? It's this temperature difference between the water vapor and the cooler surface that actually affect the rate of condensation. So we look at this. Here I have condensation forming on the outside because this is my cooler surface. But here I have condensation forming on the inside because this is my cooler surface. So then the question comes up, where is my warmer water vapor? In this case, warmer water vapor is in the surroundings, whereas in this case, warmer water vapor is inside. So when we look at this, yeah, electrocution, yes, nice. Yeah, exactly. Okay, so what happens, what forms, where do these water droplets come from? It is water vapor in the surroundings condense into water droplets, right? And in order for that to happen, the water vapor must be warmer, so this process is condensation. And if I look at this, I know that this has cold water because the water vapor in the surrounding is warmer, whereas this has hot water because the water vapor from the water is warmer than the surroundings. Cool? So I know the temperature of the water in beaker X is lower than the temperature of the water in beaker Y. Okay, these questions you can try it on your own. right? Puddle of water evaporating, all of these, you can try it on your own. Now we look at these graphs. An ice block was taken out of a freezer and left on a kitchen table and then heated. So in this case, we look at this, there is ice that is gaining heat throughout. Ice is gaining heat throughout. But if you notice at 2 points of this graph, the temperature does not change. And remember, it goes back to, what is the light goal? Huh? What is light goal? I don't know. What is light goal? What is the light goal? Oh, what is the goal? The goal is to hopefully understand water and its states and do well for PSLE. Okay, so remember, when an object gains heat or when an object loses heat, either it changes in temperature or has a change in state. So if you look at this, there's 2 parts where there's a change in state and there's 1 part where there's a change in temperature. Oh, I need about 50,000. Oh, the goal, light goal. Oh, Inaya, thank you. There will be a light goal. Yeah, this is 50,000, but I'm like at 3,000 now. So unless we keep smashing it all the way, right? But eventually, even if you don't get the Dubai chocolate, don't worry, it's still like a popular voucher. But of course, the Dubai chocolate is a much more treasured prize to get. Right? Thank you. What, Inaya? Excellent. Okay, so during AB, you notice here, this part, what is happening is the water is changing state. And what state is changing? It's called melting. And this part again, the water is changing state. And during these two, AB and CD, the water is still gaining heat. I repeat, the water is still gaining heat. So again, ice is melting and going through the, ice is gaining heat and going through the process of melting. The temperature doesn't change because all the heat energy is used to change state and not change temperature. So during the melting point, the temperature doesn't change. And if they ask you why, remember, if they ask you why, in PSLE you have to state all the heat energy is used to change the state and not change the temperature. Because 0 degrees is the melting point of ice. At point B right here, all the ice has melted and it is all water, no more ice. When it all becomes water, the temperature can start to rise. So the ice has melted into water. Not just melted, completely melted. There's no more ice left. Then its temperature can start to go up. And again, it's gaining heat from the heat source, right? It was heated with maybe some fire or something, so it's gaining heat from that, right? At C, at this point, when it reaches 100 degrees, this is where it starts to boil. Okay, at C, the water starts to boil and water becomes steam. Why is that? Because at 100 degrees, it is the boiling point of water. And throughout the boiling, the water continues to gain heat and boil, and its temperature doesn't change because, I repeat, all the heat energy is used to change its state, not change the temperature. Okay? And its temperature remains constant. It will only start to increase after all the water has become steam, right? But steam has kinetic energy, right? For those of us who have learned kinetic energy already in school, right? The kinetic energy means the steam will start to escape. It doesn't have a fixed shape. It can go all over the place. Unless you have it in an enclosed space, you can't really heat up the steam to higher, which is where the misconception that steam cannot be hotter than 100 degrees comes from. But if you enclose steam, you can heat it up to really, really high, right? At BC, the water just continues to gain heat, and the first process happens, which is temperature will increase. Okay? 111. I don't know what is 111. What? 61. 11111. Okay, Jenny. Perfect. Right? It's the same thing for cooling down as well. Okay, throughout this entire state, it is actually cooling down. Okay, and you can see that on a graph. Nice. right? So basically what is freezing? Freezing is effectively when water becomes ice. So water loses heat and becomes ice. Melting is when ice gains heat and becomes water. Boiling is when water gains heat and becomes steam. And evaporation is when water gains heat, but instead of becoming steam, it becomes a gas, and we call it water vapor. And last but not least, condensation is when water vapor or steam lose heat and they become water. Okay, cool. So now we know, yeah, easy, excellent, Kiang, thank you. Yeah. So coming back, final thing, what affects the rate of evaporation? So now we know what affects boiling, what affects melting, what affects freezing is basically impurities. We know what affects condensation is the temperature difference between the warmer water vapor and the cooler surface. And finally we come to what affects the rate of evaporation. Okay, we look at what affects the rate of evaporation. Okay. One second, got a stuck. There we go. So we're going to look at what affects the rate of evaporation. Rate of evaporation talks about how fast water can become water vapor, right? For example, your clothes that are wet, how do I make it dry faster, right? It's happened to me quite a few times when I go to the washroom. For example, I just spill water on my sleeves and my sleeves are wet and I need to get it dry. So what I do is I get it under the hair dryer, because the hair dryer has two things. It has heat, it has temperature, and it has wind, and both of these affect the rate of evaporation. Okay, so a faster rate of evaporation means water becomes water vapor faster, and a slower rate of evaporation means, or we say a higher rate of evaporation and a lower rate of evaporation means water evaporates into water vapor slower. Now I repeat, for water to become water vapor, right, it needs to gain heat, and this gaining of heat happens only at the surface. I repeat, it happens at the surface of the water, which is why, unlike boiling, you don't really see bubbles that form. So if you look at these two, right, one of them is exposed surface area. How much surface area is, wow, Inaya, excellent, she knows everything. Nice. Promoting us. Thank you, Inaya. Okay. So if you look at exposed surface area, right, when there's more exposed surface area, you see more water particles can actually gain heat and they can become water vapor. If I compare number 1 and number 2, of course there is more in number 1 than in number 2. And that is what we call the exposed surface area. So the first thing is the exposed surface area of the water in contact with the surroundings will affect. So the higher greater the exposed surface area, the higher rate of evaporation. Right? The second thing that happens is when these water molecules start to rise up, right? Now they're gas, you can't see them, I'm just drawing them, right? I'm just drawing them as a gas, right? They're stationed there. Oh my God, Aicha, Riz. Primary, what is this? Primary 5, actually primary 6, because it's towards the end of primary 5. Some schools started earlier. Okay, so imagine there is a wind that blows this, right? So a wind comes and blows all these water away, right? It blows off these water droplets away. So what then happens is the next batch of water can actually come back, right? So the wind will come and blow it away, right? And the next batch of water will come back, right? So that is what keeps happening. Okay, so again the wind comes and blows it away, then the next batch can come back, right? And the wind comes and blows it away again, and the next batch. And that is why the presence of wind affects the rate of evaporation. And last but not least, in order for water to evaporate, it needs to have heat. So the greater the temperature, the higher the temperature, there is more heat for the water to gain, right? So more water can gain heat and evaporate faster. So all of these three, when you increase it, it increases a rate of evaporation. Okay, cool. Right, so this gives us a brief overview of water and its states. Pretty good topic. The few key points that I really need you to remember, key points like what happens when water gains heat, either change in state or change in temperature. Another key point is the heat energy is used to change the state and not change the temperature during melting and boiling, or the heat energy lost is used to change state and not temperature during freezing. Okay, so right now I want you guys to get into Kahoot. Okay, I'm going to play a Kahoot game. Okay, we're going to host this Kahoot here. Come. So this is your Kahoot pin. Right. I'm going to start this. Quickly get ready to join. Sure, is reaching 8K likes. Yes, Nadia, let's go. To the moon. Right. 2 weeks back, I think you had math. I think P5 math or P6 math. And Coach Shaira was like, hey, right, I got like 100K likes easily. There's only 9 people in the live. Yeah. You've been spamming. Wow. 9 people got 8,000 likes. Excellent. Wow. Can you imagine if there's like 29 people? Yeah. You, Nadia, hi. Cool. Yeah. Okay, let's wait for people to join. Come. Now this one, if you win, you'll definitely get something. I doubt we're going to get some chocolates because we're way off the chocolate mark. But we'll at least get a $10 popular voucher. Okay? Come quickly join the Kahoot, those of us who are online. Dr. Lark. Cool. I do. Nice. Nice. I have mountain turtle. Okay, we have about 8-9 minutes on this. So, I guess we only have 10 of us here, so we'll just cute gazelle. Guys, it's pretty easy, trust me. It's a pretty easy thing. Which one did I? Cool, thank you. Okay, let's quickly go in. Okay, since there's only 10-11 of us, okay, there's about, nice, okay. I think all 7 of us are here joining. Thank you. I'll just give you a few more minutes and then I'll start at 6:51. Okay. Okay, nice. Sure, there we go. There's 8 of us. Let's go. It's just 8 of us. I think it becomes easier. You're a wise glider. Okay, good luck, wise glider. Let's see. Question number 1. Okay, what happens when liquid becomes gas? Remember, liquid to gas. Liquid becoming gas. Gas can either be water vapor or steam. Which of these processes changes liquid to gas? I have 8 answers. Cool, right? All of us got this. Excellent. Let's see who was the fastest. Smart Koala. Thank you. Right, evaporation and boiling are both processes where liquid changes state. Okay. What is the process called when gas becomes liquid? Gas becomes liquid. Again, straightforward. Basic questions, right? It's not melting. Melting is when solid becomes liquid, right? In this case, it is liquid become gas. Smart Koala, not bad. Hey. Code is 818072. Yes, it's just right at the bottom of your... Oh, it's not at the bottom of your screen. Let me see why it is. There it is. Okay, now it's at the bottom of your screen. Okay. Oh, oops. Hey. I was way off screen. There it is. Okay. Right. Good. This is condensation. Okay. Next question. the temperature of water reaches something and water becomes from liquid to a solid, which means water becoming ice. What do you think that process is called? Water becoming ice. Water becoming ice. Cool. Right. Okay. Nice. It's not melting. Remember, melting is the opposite of this. This is freezing. Okay, good. All of us get this. Next. Just now we just spoke about it. Rate of evaporation. When I have more exposed surface area, more water can, yes, it is greater. Very good. Next. Okay. I know that was very fast, right? The greater the exposed surface area, more water is exposed to the surroundings, more water can gain heat and evaporate faster. So the greater exposed surface area gives you a greater rate of evaporation. Question number 9. Temperature of water reaches 100 degrees. Remember, 100 degrees. 100 degrees, is it water vapor still? Is it still water vapor? It's actually steam, right? At 100 degrees, it is steam. At temperatures below 100 degrees, we say evaporation becomes water vapor. Oh, this one is split right down the middle. Cool. Half of us thought it's water vapor. Okay. To be fair, yes. Now, you know, more recently scientists do call, sometimes they call water in the gas form as water vapor, even though it's at a high temperature. But more accurately, in Singapore's context, it is called steam. Nice. Okay, so the boiling point of pure water is 100 degrees Celsius. Okay. Question number, water can evaporate. Do you think ice can evaporate? Do you think ice can evaporate? You're learning this here. Yes, Jocelyn, you will learn it just well. No, remember, when ice becomes a gas, we call it sublimation. Water or evaporation happens between 0 degrees and 100 degrees. Okay, 0 degrees and 100 degrees. So when water becomes water vapor, we say it's evaporation. But when ice becomes water vapor, it's called sublimation. We went through that a little bit today. Cool. Hey, I'm seeing some nice thumbs ups there. Adding salt to water increases the boiling point. We spoke about impurities. How does impurities affect boiling and melting? Right? How does impurities affect boiling and melting? Oh, okay. So we missed that part of the lesson, some of us, right? We have 6 correct, 4 wrong. Again, pretty much in the middle. Right? Remember this, right? Impurities, they raise the boiling point, but they lower the freezing and melting point. Okay? Again, if you had gone back and learned, listened to me earlier, I would have said, please go and look up this particle theory of matter. It's very useful. There's videos that are, at your level, at a child's level. You don't need complex science concepts to understand the particle theory of matter. It's a very basic concept, and there's some pretty easy to understand videos that are there. Cool. Next question. Let's go. Yeah. Wet clothes, they dry faster. What are the factors that affect the rate of evaporation? On a cold day, the temperature is lower. What do you think? True or false? Make a guess. Actually, it's not true. Okay? The temperature plays a bigger role because remember, it's about water gaining heat. When the water vapor rises up, the wind blows it away, the next layer of water vapor can rise. But if there's not enough heat, okay, if there's not enough heat, right, if there's not enough heat, where will the water gain heat from? So temperature plays a much bigger role than, in this case, this one, right? What am I saying? Then the presence of wind. Yes, presence of wind affects, but presence of wind, all it does is just carries the water vapor away. Just carries the water vapor away, and the temperature is more important because the water needs to gain heat in order to become water vapor. Cool. Okay, now this is the last question. So just now, I don't know who was in the lead, right? The person who's leading, right, after this last question, in fact, all of us can get ready. We need to take a screenshot of 2 things. Number 1, take a screenshot of this little QR code over here, and take a screenshot of the next screen at the end of the Kahoot game, which shows you that you're in the first place. After that, go and log into this, go to the link on this QR code. Why? Because this QR code will be a form. It'll take you to a form, and if you're in the first place, you go in there, you submit your name, you submit your address, and they'll send you the popular voucher. Or let's see if I can convince them to do it, Dubai chocolate, right? We're almost at 9K. I needed 50 at least, but let's just see what the guys say. I'll try my best, and we'll see how it goes. Okay, cool. So remember, those especially in the podium, try and take a screenshot now. I'll give you a few seconds, and take a screenshot of this and the last page, which shows you're in the first place. You will need those two screenshots in order to claim your popular voucher. It's a $10, pretty good deal. Okay, let's go. Just to spend your Thursday evening with me. Evaporation happens throughout the surf liquid. Do you think it happens throughout the liquid? True or false? Hey guys, again we're split right down the middle. Okay, these are all very important concepts, and in fact they're basic concepts we need to master, right? Evaporation does not happen throughout the liquid. Yes, Viviana, it doesn't happen throughout the liquid. See, these are some differences between boiling and liquid evaporation, right? Boiling takes place at a fixed temperature, which is 100 degrees for water. And because boiling happens throughout the liquid, every spot is gaining heat. Every spot is gaining heat. You see these bubbles where water becomes steam, right? And that is what the bubbles are. What is in those bubbles when it's boiling? It's gas water. It's water in the gas form. Okay? And water becomes steam. However, during evaporation, it takes place between 0 and 100 degrees, right? And you can't see bubbles. Why is it you can't see bubbles? Because it is happening only at the surface of the water. You see, it is happening at the surface of the water right here. However, boiling happens throughout, here, anywhere, right? Because the heat source that is given to it is probably from underneath. Okay, so that is one very important distinction. Connection laws do not refresh. Okay, that's one very important distinction we need to remember. Number one, boiling happens at a fixed temperature. Evaporation happens at any temperature. Number two, boiling happens throughout the liquid, whereas evaporation happens only on the surface of the liquid. And both processes involve a heat gain, and both processes involve liquid becoming gas. Okay, so now let's see who is our winner. Let's see. Helpful kitten, well done. Good job. Rational deer, excellent. And in first place, we have Wise Glider. Hey, Wise Glider. Somebody said they were Wise Glider. Is it Nadia? Nadia, were you Wise Glider? Yeah, Wise Glider. Nadia, take a picture of this. Okay. Nadia, take a picture of this. Yes, take a screenshot of this on your phone. On your phone. Okay, take a screenshot of this on your phone so that you can go back to that QR code, scan it, and claim your prize. Okay, easy. Thank you. Thank you guys for joining me today. It was wonderful having you. Thank you for spending a Thursday afternoon with us. We will do this every 2 weeks. You're helpful kitten. Well done, Julian. Good job. You're still on the podium. Right? Okay. I'll see you again in 2 weeks. Every 2 weeks we'll have it. Now during the fasting month, we're going to do it between 6 and 7 p.m. But after the fasting month, once it goes back to our regular weeks, we'll do it from 8:15 to 9:15. So it's a little later. I know some of us may need to sleep, but again, thank you guys for joining me today. Again, I'm Coach Ryan. I'm from BrainyMoScience right here at Master Math. Visit us at our Telegram channel right there for more resources. Okay, and thank you for all your likes. Right? Okay. Thank you again. Thank you, Inaya. Thank you, Nadia. Thank you, Julian. Thank you, Viviana. All those guys who are with us. Thank you. Okay. And I'll see you kids again. If you join me, I'll see you in 2 weeks. Right? Of course, don't forget they have math lessons that happen as well. Math lessons happen weekly. Your primary school math and your secondary school math. Okay? Again, this is Coach Ryan signing out. Bye. Bye, guys. Thank you. Bye. Bye, bye, Naya. Bye, Nadia. Thank you. Okay. Bye, guys. Bye.